Hey everyone, welcome to my channel. So in this video, I'm going to cover the system design question called designing a weather monitoring system. So first of all, let's see the background. So suppose we have 10 million temperature sensors deployed around a georegion. So for example, deploying the whole US homeland. So we have the sensors that can communicate with HTTP protocol, and this is going to generate a payload per 30 seconds. So we want to design a system to collect the temperature data and show the current temperature, the low and high temperature for the last 7 days. So that's pretty much the background. So it's pretty solid background definition, but first of all, we still need to understand the scope of this system design question, because there's still something we need to try to clarify before you can get to the next step. So the scope. So what is the scope? We need to see what are the feature requests and what are the non-goals. So I would assume the first feature request is we need to have something like the backend or the pipeline stuff to collect the weather or temperature data and store it storing in the database. So first of all, I need to have like the backend part design. So let's say you're not going to, and also we need to have a front end to actually display the weather information to the users. So let's say we are not going to cover like the UI UX or the mobile part. We are not going to cover some such things. So we are mostly focusing on like the backend part. So the next thing I want to focus on is what about the time zone? So do we support the time zone stuff? And it says that it is going to be deployed on the geo region, so we definitely want to clarify whether it is like there is some internationalization, like we have APAC Europe and North America. Let's say we only focus on US, so we are just deploying the sensors in the whole US homeland. So scope, let's say it is only for US, and we need to support the different time zones, and need to support time zone. So this is a thing. So the next thing I want to think about is, do we need to have like the monitor on top of this monitor? So for example, it's very easy for some sensors to be down. So are we going to like have some monitor stuff, something like that? Let's say we are also going to cover the monitor stuff, monitor the house of sensor, etc. Let's say we are going to cover that as well. So I think that's pretty much it. So some non-goals, I would say just weather, just temperature, no other info like rain or snow, wind, so we are not going to cover that. So just the temperature, current temperature, and the low high temperature for each of the day for the last 7 days. So that's pretty much it about the thing. So scoping, we should be pretty much in good shape for this one. So next one, let's do some constraints analysis, so that we can get some numbers to see what is the scale of the system we are trying to design, and try to get some useful information to proceed in the next step. For example, some storage analysis, some traffic analysis, which can help us understand the problem better. So first of all, I want to see about the traffic analysis. So let's say currently we have 10 million temperature sensors, and each sensor is going to send HTTP request per 30 seconds. So it's something like 20 million requests per minute. So it's something like times 10 to the power of 6 divided by 60, which is 60 seconds per minute. So it's something like we are looking around. So this is 1/3 of. Okay, so it's like 300k kps, something like that. So okay, so it's something like a 300k kps. Not too much of the traffic, but still but quite significant, but not too much, not that much. So 10 million, okay, 10 million, so 20 million requests. Yes, just want to make sure that I got the numbers correctly. Yes, I think it's correctly. So let's say for the peak time you have like 600k kps for the peak time. So usually a normal server can like hold like 1k or 10k of the kps there, so not too much of the traffic, because the payload is not going to be very expensive for us to process actually. So quite significant traffic, but not that much. The next one is about, let's do some storage analysis. So for the storage, we definitely need to have the sensors. So 10 million sensor, I think not too much of a big deal regarding the schema. So let's say each of the sensor is going to like take 100 bytes, I would say. That is 10 million, so it's just 10 million sensor is just going to be 1 gigabytes for the schema of the sensor. And then the next thing I want to think about is like the real, this is okay, so this is a sensor schema, and then the other thing is the temperature data. So for the temperature data, we are actually storing, so we are just looking around 7 days high and low temperature and the current temperature. So we don't really need to worry about like storing the whole history of each of the payload. So we are not going to store them out. But probably we can store like that, in the log. Like we can have some temperature data in, let's say this is the DD part, and then we can have some log. So the log stuff, I would say for the log stuff, you're having 20 million per minute, 20 million per minute. So each like 60 minutes per hour and 24 hours, something like that. So like this is for each day. So let's say we are going to store for TTL is going to be 30 days. Then it is about this is 20 million. Just want to make sure this is 10, 10. This is 2. This is 2. Let's say each of the payload it is worth for. Let's say it is each of the payload is going to be worth for like 10 bytes, I would say. So if it is 10 bytes, then we are looking around. This is 20 million times. Let's say this one is this is 120, 120. So this is 120. Let's say this is 1k, and then this is 300. So it's something like this. So this would be 1k times 1k times 1 million times 6. So this is something like this is 1 GB. So 1 GB, 1 TB, and 6 TB of the log for a month, for a whole month. But if you want to have the TTL, so this is a TTL as equal to 30 day. So if you want to have longer TTL, then it may be we may need to have some more storage. So 6 TB, not too much. For temperature data, for the database part, we have 10 million sensor, and let's say for each of the sensor, you're going to store the current temperature and the last 7-day high-low temperature. So it is going to worth about, let's say each one it's like a 4 bytes. Let's just give it like a 20 bytes for each of the entry. Then it is around 200. Sorry, this is about 200 million. So 200 megabytes for the real-time database, I would say. But in case we have different regions, so let's say, because for this one, from the user perspective, they may zoom in or zoom out. For example, they may want to take a look at the specific sensor, or they can zoom out, zoom in, zoom out, and see like for example the temperature in the Los Angeles area, so something like that. So let's say we may need to give this like a times 5 or maybe times 10. If you give this times 10, it's just like a 2 gigabytes of the data. So regarding storage analysis, this is something like that. So we have 10 million sensors. It doesn't make too much of the difference whether we use RDBMS or we use NoSQL. And for the temperature database, I think it doesn't make too much of the difference either. What we could do, but for better scalability in the future, let's say we have like a billion sensor adding on top of that, then we may need to design using the NoSQL to store the data for better scalability. So I think that's pretty much it about the storage analysis. Some other requirement like the reliability, or maybe just say availability. Availability. So let's say for the availability, from the user's perspective, when I say the user, is actually the user who uses the front end to take a look at the data. So let's say the whole system is going to, and also regarding the data freshness part, we also need to make sure about the data freshness. So let's say for the whole system, the availability is going to be, let's say 99.99 availability. And also because we have some high availability, then it is consistency. We are just looking at eventual consistency, and also something like scalability. So for the scalability, we're designing is very highly scalable system, and something like other things like durability, something like that. Essentially, we are designing a distributed system which is highly scalable, highly available, has eventual consistency. So that's pretty much it about this part, constraints analysis. Let's see the next part, which is general design or general architecture design. General design part. So for this part, it's mostly about focusing on the general architecture or the general infrastructure of the whole system. So let's say so there are two different things, the sensor and the user. So first of all, the sensor is going to send some HTTP request to our server. So first of all, it is going to hit a load balancer, and then it is a front-end server. And then the front-end server is going to translate the payload into protobuffer and send the RPC request to the backend server. And then the backend server is going to further store the data into the database. So until now, I think we should be good. And then there is another type of the user, which is the I'll say which is the other the user that is going to read our data. So the user, I would say, okay, so I think it's just a similar. So the user is going to also send some HTTP traffic to our load balancer, then front-end server interpret it into protobuffer, send it back to the backend server using RPC protocol, and then we are going to have some cache layer, so in case it can help when we query the data, and then we return the response. After querying the data, we include the response as a protobuffer to the backend server. Backend server is going to send some return the response, and for the frontend server, it's going to like interpret into the JSON format, and then further return to the user, and then when it is shown to the browser, it is going to interpret the JSON object and then display the graph or the data on the front end part. So that's pretty much it about the general design, a very high level architecture design, but it should work. Let's see more about some other stuff. So for example, the detail design. So for detail design, it really depends on what the interviewer asks us to do. So for example, like which part he or she wants to dive deeper into it. So first of all, let's say I think the major part is the DB design. So the DB design, for example, what type of the database we are going to use, what is the data schema like, which tables we are going to have, something like that. Because that's the major part. After we have that defined, it is easier for us to just explain how this whole system is going to work. So let's start with this part. But again, it really depends on what the interviewer is interested in. So in case he or she wants to ask whether you're going to use pull based or push based, when I say pull or push based, is something like whether, because currently the system is using the push based, like the sensor is going to send send the payload to our server. But what if using some CS model, like the sensor is a client actually, and we have the server deployed on our side. But what if sometimes they want to use pull based? So maybe they want to ask some questions what is the pros and cons for pull or push based model. So it really depends. So you may expect such kind of questions. But it's pretty random question. I cannot tell you what is going to be asked, but just be prepared about such kind of the questions, like why you're going to use load balancer. I think you pretty much have very good knowledge why you're going to use that, because we want to try to avoid any single point of failure in distributed system design, something like that. So let's first start with the DB part. For the DB, again, what type of this database we are going to use. So like I said, for the schema things, not too many of the entries we need to care about. So I would say not too much of the difference whether you use RDBMS or NoSQL. So let's say we are going to use NoSQL here for future extensibility. Like let's say we have like much more sensor in the future, and we may consider to use NoSQL. So let's say we for the NoSQL we are going to use Bigtable, which has very high scalability. So for NoSQL, first of all we need to have the sensor table. So for the sensor table, let's say you have the row key defined as the sensor ID. So the sensor ID, the unique ID generation is very is very simple. It's something like we use the times that we can have a separate component just generating unique ID. So if you have any difficulty regarding this part, feel free to check my other videos. I have covered this kind of the component generating unique ID generation in my previous videos quite much. So we have the sensor ID as a row key, and then we have the column families. So let's say the first one is going to be the info. So you're going to store this as a proto buffer. Essentially, it is going to store, well, it could be something like the region IDs. So for example, the finance region ID, well, of course, it's a sensor ID, and on top of that, it could be something like for example, the county, a region ID can represent a county, can represent a city, can represent like a zip code. So like we can have, this is more like for the zoom in, zoom out stuff. So essentially, for each of the sensors, have different region IDs sitting on top of it, which is for us to actually use to update the last 7 days low or high temperature and the current temperature for different regions. So we will have the region IDs for each of the sensor. So let's see other information, maybe some naming stuff as a string, and maybe we have, well, I would just say some extra information currently. So maybe we need to definitely include some other things. But yeah, so currently not too much of that. And then the other thing I can think about, yeah, I think currently for the sensor, I think that's pretty much it. And the other thing is the temperature stuff. So I would say from the user perspective, this is more like so for the sensor perspective, this is a write heavy system. For the user perspective, this is a read heavy system. So for a read heavy system, usually we just pre-compute the results for the views, and then when the user try to query the data, we just get the pre-computed data. So when I say pre-computed data, it's actually the temperature data for different level of the regions. So for example, users can zoom in, zoom out, and see the weather history, the last 7 days low and high temperature for Los Angeles, for Orange County, for a specific zip code, for like a very small little area, something like that. So we don't need to actually define the geo concept for this, but we need to definitely call out the region stuff. And also it's worth to mention how we are going to represent the last 7 days low and high temperature for each of the region. So let's say we are just going to select a couple. Let's say we are going to select a couple of the sensors as the representative sensor for some region. So for example, for specific zip code, there are 3 different sensors. So whichever send the data, we just use that data to update the corresponding low and high temperature, last 7 day low high temperature for based on the data from the representative sensors. So it will be something like that. And this one is already covered in our region IDs. So for the temperature, I would say the row key, of course, it is the region ID. And then for the column families, we are going to have another thing which we will call it the info. So for the info stuff, oh, okay, so by the way, I think there is another thing I need to definitely include in the info part, which is a time zone. So time zone, it's essentially telling us that the local time zone of the sensor. But in case, I would say there is something we need to definitely call out: the restriction of the sensor. So the sensor can represent different regions, but the region shouldn't be located in different time zone. So I think so. For example, yeah, let's say we it really depends on the business requirement. I think currently, if the region, if the sensor can be located in different regions, and each region can have definitely have different time zones, we can have like a pair of the ID and the time zone, and then we have like a repeated field of the pair. But let's assume that each sensor, for even for different level of the regions, it is still in the same time zone. Let's have this kind of hypothesis for the current system. And then let's continue for the temperature table design. So we have the region ID. For the info, we are going to have the current temperature, and also we are going to have a repeated field. Let's say we have a repeated field, or maybe we just have another. So let's say we have a proto. So the proto essentially is actually the date, which is the local date, and also the corresponding temperature, low temperature and high temperature. So for this one, it is a repeated field, and as we go on, we are not going. Let's say we just need to keep like the last 7 days data for this one, but let's say we have some GC strategy set up for this field to actually set it. Well, it could be. Well, this could also be like having it as separate column. Well, let's okay. That depends on the design choice actually. So you can actually have that as different. So maybe we can have. So let's do it in this way. So let's say we have the column family for each of the columns. So we have different columns. So for this column, it's like the current temperature, and then the current temperature is going to have. So this column family. Let's say it's temperature, and then the corresponding column is current temperature, which is used to record the current temperature, and there are different columns for the date. And then we have the GC set up as, let's say, 10 days. Then as long as the data is out of the 10-day stuff, it is going to be GC if it is out of the 10-day TTL. So this one, we actually have this one. We have the date as a different column, and then we have the low and high temperature stored as protobuffer for the corresponding column. So that's pretty much it about the temperature stuff. The temperature stuff design. So let's see the next one. What other things do we need to have, like the sensor? Let's go through the data flow here. So let's say a sensor send a HTTP request including the sensor ID and the corresponding payload, like the temperature, to our front-end server, and then we turn it into protobuffer, send RPC request to our backend server. So first of all, the backend server is going to try to query the sensor data based on the sensor ID from the cache about the region, different region IDs, and the time zone, and then further based on the time zone, it is going to calculate the local date of the local date, and then further update each of the region ID, and then further update each of the region ID for the temperature table about the current temperature, the low and high temperature for the corresponding local date, and then store that. And let's say if a user is going to query the temperature data So first of all, it is going to send the region ID. Um, I guess there could be some way, like you may need to have another thing, maybe like key value stuff. So for example, suppose so that's like the region stuff. We need to try to, like, when the user zoom in or zoom out, we need to try to understand which region ID it is the user is targeting at. Well, let's say we have like another component try to turning the 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 GPS stuff into the region ID. Let's say that's already there, and then we send the region ID to our backend server. Then we are just getting the current temperature, last 7 days, low and high temperature to be returned to our user. So I think it's okay to talk about like how we are going to turn how to interpret which region ID the user is currently looking at. So for that, yeah, it depends on the interviewer. So the interviewer, if the interviewer asks us about this kind of the question, I think, so I think one thing I can think about is, so for example, if he or she is looking at like a city, we may need to have like a mapping stuff to be stored in the cache. So based on that, we try to get the region ID. So it'll be something like that. If it is more complex, if it is more complex, we may need to think about some geo-indexing stuff like quadtree or rtree stuff. But it really depends on the business requirement here. So and also it depends on scope of our interview. So we may or may not be able to cover that during the interview. So I would say that's pretty much it. We have pretty much everything here, and based on the things we use, it is highly scalable. Like we use NoSQL. We don't need to worry too much about sharding stuff because the Tablet server, if it's too hot, it is going to further split. So like sharding stuff, we don't need to worry about that. So we definitely need to have some duplication set up, like the master slave stuff set up, so that we can have some duplicates to make sure we don't lose any data in case there is some data center disaster. And also for the cache, we could use memcached for this one. For front-end server, back-end server, there is a load balancer in front of it, so we have elastic load balancing. So in case there is a higher amount of the traffic, then we are just going to add more of the front-end server or back-end server on top automatically. I think until now we have pretty much everything here. Let's see if there's anything else missed. So currently we are already fulfilling the first feature request. For the second one, we already support the time zone. Okay, so the last one, I think I missed the monitor to the house of the sensor. So how are we going to monitor the sensor, the house of each of the sensor? So for the current temperature, so remember we actually have okay, so the region ID. So remember for the big table, we have the timestamp stuff. So let's say for each of the sensor, it's essentially sending a payload every 30 seconds. So for this region ID stuff, the finest region is actually the sensor ID. So in the temperature table, the current temperature has a corresponding timestamp, which is actually the last timestamp we receive the payload from the sensor. So what you could do is we could we could have like another thing, like a monitoring component that is going to try to query this for each of the sensor. It is going to query the timestamp of the current temperature. That is going to get the latest payload sent from the sensor. So in case the timestamp is too old, let's say it depends on our SO. So let's say if the timestamp is older than 30 minutes, then we are going to mark it as unhealthy. Then we may have like a dashboard, or we may have some paging stuff set up on top of that. So in case and also it depends on how important the sensor is. Suppose the sensor is representing like a region, like an important region, then we definitely need to page the stuff to see what happens and try to fix the sensor. And remember, for each of the region, we have some duplicate sensors there set up. So in case just one sensor is down, then we have other representative sensors to keep sending the temperature to our system. So that one, I think it is going to survive about some kind of the disaster from the sensors, like some sensor, in case one or two sensor get down, or maybe like a 1% of the sensor get down, our system can still survive. So we may need to make sure about that. But from the monitoring perspective, what we could do is we just keep track of the timestamp of the current temperature for each of the sensor. Try to see the last the oldest one, the oldest timestamp. So which just seems like so this like for each time the sensor send a payload to us, it's also used except for the temperature information, it's also used like a heartbeat for us to monitor actually. So that's just like a different component trying to query the data. So not too much to worry about it. And I would say that's pretty much it about this system design question. So if you have any question regarding whatever, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.